This lesson attempts to explain the difference between expressions and equations, as well as the difference when a problem says to simplify an expression versus to solve an equation. First, let's be clear about what we mean by an expression. An expression is just a series of mathematical terms. Those may include variables like x or y or p or q, and constants. Those are plain old numbers like 3 and 5 and a million and 0.06. The expression does not necessarily have to be equal to anything. Sometimes it will be, but sometimes it might not be. We may have a constant expression, that is an expression whose value never changes. And an example of that would be this expression, 3 plus 5 minus 2. In this case, all of the terms are constants, 3, 5, 2. And the value of this expression is always equal to 6. 3 plus 5 is 8, minus 2 is 6. This is a constant expression. We may also have a variable expression. That would look something like this, 3x plus 5 minus 2. The value of this expression depends entirely on what number we plug in for x. So the value of the first expression is always the same. Its value is constant. But the value of the second expression varies depending on what x is. The value of that expression is variable, and so we call it a variable expression. We can simplify expressions. That means to rewrite them in a way that has the same value, but is simpler. One way we can simplify is by doing things like combining like terms and applying the distributive property. So here's an example of a fairly complicated looking expression. 3x minus 5 plus 2x minus 3 times the quantity x plus 1. If you pause this presentation and do the distributive property first, and then combine the like terms here, you'll see that this simplifies to 2x minus 8. This is a much simpler way of writing the same quantity. Notice that x could be any number. The value of this expression simply depends on what we decide to plug in for x. We can't solve variable expressions. There's no solution to this expression because it isn't required to be held equal to anything. Can do is you can evaluate expressions. You can evaluate a variable expression for a particular value of the variable. I'll give you an example to help you see what this sentence means. In this case, evaluate just means to see what an expression turns out to be, what it becomes equal to, when you plug a certain number in for the variable. So a problem on a test might say, evaluate the expression 2x minus 8 when x equals 3. That means take the expression 2x minus 8 and plug in a 3 where there was an x. Replace the x with a 3. So now that expression becomes 2 times 3 minus 8. Well, 2 times 3 is 6, so this expression simplifies to 6 minus 8, which is equal to negative 2. So I can evaluate an expression when I plug in a particular number for the variable. But I can't solve an expression because I could plug in all different kinds of numbers for x. I could plug in x equals 4, or x equals 10, or x equals 0. And I could evaluate the expression for each of those different values of x, and it would turn out to be a different number each time. In equations, it's important to notice that one side is equal to the other. Equations have an equal sign in them. Below are two examples of equations. The first one, 3 plus 2 equals 5. That's a simple math fact expressed as an equation. We know that when we add 3 and 2 together, we do indeed get 5. So the two sides of that equation are equal to each other. They're two different ways of expressing the same quantity. The second example, 2x plus 6 equals 8, has a variable in it. And in order to make that expression be true, in order to make 2x plus 6 actually be equal to 8, there's only certain numbers that we're allowed to plug in for x. Some numbers, when we plug them in for x, do indeed make the left side equal 8, but some numbers don't. In order to find what value we want to plug in for x to make an equation true, we have to solve that equation. You can solve an equation by finding out what makes one side be equal to the other, what makes it actually be equal. Here's an example from the previous slide. We're going to solve the equation 2x plus 6 equals 8. We go through a series of steps to get x all by itself here. And when we do that, we see that x has to be 1 in order to make this equation be true. When I plug in a 1 for x in the equation, the left-hand side becomes 2 plus 6, and that does indeed equal 8. A really important thing to understand, when you go through the steps of solving for x, what you're doing is you're figuring out what number you have to plug in for that variable, x, that makes the two sides of the equation actually be equal to each other.